Hi, and today we're going to look at rearranging equations and formulas. So this is sometimes referred to as making something the subject. So just like solving an equation, we're going to go through the same process, same steps. So one step, two step, and then kind of more complex multi-step problems. After that, we're going to learn how to rearrange using flowcharts, okay? And then how to actually put in values as well into flowcharts and find out how to solve for different variables, even when not given an equation. And lastly, we'll kind of form equations from worded expressions and then learn how to rearrange those. So, first step, let's go through kind of a brief showdown of what's going to happen. So, it's very similar to solving an equation. The only difference from rearranging formula to solving an equation is that we're not going to get an actual value out. So we won't get something where it's x equals some number. Typically, it's an expression in terms of other formula. That's why it's called rearranging formula, because formula is described as having two or more variables, right? So it will allow us to manipulate them, and then we can just substitute values in later. So generally, steps to rearranging are as such. So given this, x equals t bracket v plus 1/2 at bracket. We want, well, we don't actually know what we're going to solve for, so let's make I'm going to choose A, the subject. That means, in the end, I'm going to want our expression as A equals, and then whatever we result in. So first off, anytime we did solving, same thing here, we want to get rid of brackets, right? Brackets aren't our friends, they just mess up everything. So let's multiply into our brackets. So I'm just going to rewrite our equation really quickly right here, just so I can kind of annotate it a little bit. Okay, so let's first expand our brackets. So, whoops, that means we're multiplying this t by our v, and so we're going to get tv plus, and then we're doing t times positive 1/2 at squared. So we're going to get a positive, and that's going to be 1/2 at squared. Okay? And of course, x equals, because we need to keep using that x equals. Notice how I've lined up my equal signs here. That's just convention in maths. So isolate the subject from the other, so using addition or subtraction. So we know that we want this term left alone. So we're going to look at moving this term to that side. So how do we do that? Well, same thing. We subtract tv from either side. So x minus tv equals 1/2 a. And actually, I'm going to just take a second to just rearrange this because I want to show you a little trick. So let's put our a just on the outside there. That means, really, this next step we're going to do, we want to keep everything left of that line. Okay? So that means, to find one of that, we'd want to just divide by this 1/2 at squared. So what that ends up doing over here is we divide over here by our 1/2 at squared. Or sorry, not a. Sorry, I made a mistake there. Just so used to, because that's actually an equation from physics that you might get to use. So on the left hand side, we have x minus t v over 1/2 t squared, and that's going to be equal to a. So I'm going to write it always as a equals, okay? And then I'm going to x minus t v over t squared, and I'm actually going to write the 2 up top with brackets around, saying that's times by everything, just because we don't want to leave fractions in a denominator. It's bad to have fractions inside fractions, basically. So how we do that is we multiply the entire thing by 2. Alright, so there we have it.